Alright everybody, so I wanted to do a quick video with just some basic tutorial stuff for Rhino. I know I kind of jumped into it a little bit last time, and I showed you how to make some parts of the object, but we're actually going to get a little bit more in depth than that, because I didn't explain fully why I did what I did 100% of the time. So let's go over some parts of Rhino. Right, so we have curves, which are basically lines, curves, circles. If I put down a circle here, this is not something I can render. If I put this in my window and I try to render this, nothing, right? Nothing happens. This is just a curve. If on the other hand, I want to move this up and I change this, I go to Surface, Extrude Curve Straight. Now we're taking these curves and we're pushing them up, right? Now we have a surface, but a surface is not a solid object because it doesn't have any closed faces. So if I were to go to try and 3D print this, this is a wall with no dimension. In other words, this is a piece of paper. Can't print that. So how do we fix something like that? Well, there's a couple ways we could do this. The first is we go to solid and we do what's called cap planar holes. And it'll run a detection and look at the current wall and see if that could be capped. So we'll go and cap that. And you can see the top and the bottom have been closed. Now this is a solid object. If we were to print this, what we would see is just a giant cylinder. It's not empty. This would be seen as a solid object it wants to print. Now the second way you can do this is by just starting by making a solid object. So if we go in here, this is the solids right here, the default solids. We right click and we can go to cylinder, and then we can go in here, and now it's going to give us a height, and when we click this it starts as a solid object. That's what we want. Perfect. Okay. Now let's say we don't want to print this solid object. We want to print something like this that's just a cylinder, that's a wall, but it's hollow in the middle. There's a couple ways that we could do that. We could do the complicated way, which is to draw another circle and do this and then extrude this up and then cap the planar holes, or we could just draw another solid. So we do this, draw another solid here. Just a little bit smaller than this in diameter. Now, there's a trick. We're going to make this bigger and taller as far as height, right, than the original one. And we're going to drag this up. So we're going to make a cup, right? Let's just make this just a cup. Now, there's a reason I did this, and you'll see here in a second. I'll explain. This needs to be a little bit taller so that this is intersecting with this object, but not all the way through the bottom, because the bottom needs to have a solid surface, right? So this is going to be like a 1 millimeter wall. And what we're going to do is a Boolean difference. And what that means is it's going to take the object here, and it's going to remove the other object from it, and whatever's left over, that's the difference of those, right? So that's going to go ahead and leave behind, should be the shape of this cup. So we start by clicking on the object we want to keep, selecting difference, and clicking the one that we want to subtract from it, and then pressing enter. And you can see now, this is a cup. Not the world's greatest cup, of course. The idea behind this is just to give you an idea what these do, sort of what all these functions can do. Now there's something else that we can do, which is a Boolean add, right? We can do a union. So let's say that we want to make a handle for this cup. We would go ahead and create that in here. We'd create a nice little U, and then we would cap the planar holes. Well, actually, we can probably go ahead and do that. Let's do that. We're going to make the world's worst handle. And of course, now we need to take a circle here, put that on the end, drag that up so it's in line with the bottom of this guy, And we are going to sweep a rail. Sweep one rail. So we're going to select the rail. And then we're going to select the shape. There we go. We got the world's worst looking handle. It's not the greatest. So what I just did right there, the sweep rail, is you are selecting a shape, the curve that you want that shape to go along. In this case, we chose a circle. So if I delete this and go back, I'll just kind of explain this real fast. This bottom of this circle is at the bottom of this line. They're meeting each other. And when you sweep it, it's going to take and move this all the way down in here and make a surface. Now, it's not going to make an object. The two are different, right? Remember, a bunch of closed surfaces makes a solid. And so the difference here is when you sweep a rail, the object that you want to sweep needs to be meeting that line, or it's going to be weird. Like if I make this over here, and now I select to surface sweep on rail, I select the rail, and I select this guy. Oh, we want rail, rail, shape, enter. But now it's off, right? It's off to the side. That was a little bit weird, right? We don't want that. So what we want is for it to be lined up with the line that we have. So I usually, just by principle, either do it at the top or you can do it in the middle. Middle works too if you want something that's perfectly centered. Just kind of depends on what you're going after. So now if we go back to surface and we sweep one rail and we select this, it's centered. Depends on which way you want to do it. It's fine. But if you want it symmetrical, just make sure it's not off to one side or the other. So the difference here is that we did not make a solid object, though. We just swept the rail. So these are surfaces, right? So again, closed surfaces equals a solid object. Open means it's just a surface. So you can't print a surface. If you want it to be printed, it needs to be closed. How do we do that? We go back up to solid. We cap the planar holes. Now that we have this in here, you can see we got a little bit of protrusion in here. We don't want that. But above and beyond that, these polys aren't interacting with this cup. Well, how do we get around that? Well, first and foremost, we need to make this a little bit better on the snapping, because as you can see here, the snap space is 1. We don't want that. So we're going to chop that in half. I'll explain this. When you want the grid to be a little bit more fine, you can change the snap spacing. You can keep the lines the same if you want, and you can change the spacing. In my case, I like to have my grid spacing set to usually with minor every 1, major every 10, and my snap spacing set to 1. In this case, it's 10, so we're actually working with a large object template. I usually work with small, as you saw in my previous tutorial. And what we're going to do is make sure we drag this back just a little bit so that this corner is not protruding out the edge here. If we go in here, we can see this still is a little bit. Actually, that's probably just a line. That is. Okay. All right. So now this is smooth. It's not protruding out the face. So how do we make this part of this? We're going to go back to that tool, and we're going to use Union. So we're just going to left click this guy because it's the default. As you can see, it's closed this off here. Join these faces. This is now my cup. Now if we don't want to have these harsh edges, there's another tool that we can use to clean this object up just a little bit. And it's fillet. And there's a couple of different fillet tools. If you are used to the old school Rhino, it was just fillet. And all you could do was fillet little pieces, and then you had to cut them, and then you had to trim. It was kind of a pain. Now we have this really nice tool called Edge. Edge will take a whole edge and it'll fillet the whole edge, which is really, really, really nice. It's kind of my preferred way to go. So we're going to choose fillet edge, and we're going to just select the cup. Now, 1 is not very much. That's a pretty small amount considering that this is technically a 10 millimeter edge. So what would be more reasonable? Maybe 2. If you just put the number in, it's going to know what you're doing. So we just hit 2. And you can see now up at the top where it previously said next radius 1, it says next radius 2. So we're just going to hit enter and enter. And you can see we have now filleted the edge a little bit, cleaned it up. That looks pretty good. Probably not enough for me. We're going to do more. So let's do it again. And this time we're going to do, like, let's say 5. There we go. That looks a little bit better. And you can see that that's a little bit more smooth now. So now we have rounded the edge a little bit better. It looks a little more presentable. We've got the handle on there. So these are just a couple of simple tools that you can use in Rhino to make basic objects. So instead of having to go through and I could sketch this whole handle and try to make it pop out and go 3D, or if I wanted to draw the whole cylinder, it's really not necessary to do that because of the Boolean tools. There's so many of them. There are all kinds of mesh tools. If you decide that you want to, let's say, change this, let's say you imported a file, a 3D file that was an STL, and you want to modify it, you can do what's called mesh to NURB. You can also do NURB to mesh. And you can also change the number of poly count in something if you want. If it's too many, you can kind of bring it down. Some of those files can get pretty big. But these are kind of the basics. Now, let's say you wanted to do something just a little bit more complex. Let's say I want to make a plate. And this plate needs to have bolt holes in it. Now, I could do the complicated thing, which would be to make a whole thing and make my own threads, and oh man, can that get complicated. Instead, what we're going to do is we're just going to go to the solids here. We're going to make a box. And we're just going to make a real basic, super easy plate. Nothing complicated. We're just going to do a 10 by 10. And now what I'm going to do is I'm going to import something. Okay, now that we have this created, we're going to go in here and we're going to go to insert. So we're going to browse our files. And in my case, I've already saved them under fasteners. Now if I go in here, I've got a whole bunch of different, what these are is I've converted fasteners I found online, which were in different file formats. Sometimes you just find industrial websites that you can actually download them, and they do that so that you can try them out virtually to see if they're going to fit something. But I also use them because sometimes I will order fasteners from those companies, and then I use these threads and inserts in my 3D printing so that I know that it's going to fit when I print my thing. Does that make sense? So what I do is I go in and I download those and I convert them into Rhino files so that I've got, let's say we want to do a 10 millimeter, right? M6. We're going to insert this guy. And now I have an M6 bolt thread that I can drop in here. Is this 10 millimeter? I think I might have my grid set up a little bit weird. Okay, I need to rename that. It's actually 5. But anyway, here's a 5. So let's just drop these threads in a little bit, right? Now these are pre-made bolts that have been converted. Again, a lot of these places will drop these on their website so you can see if it's going to fit with whatever your application is, which is nice. It's cool that a lot of companies do that. So I just download the most commonly used ones, convert them over, and now what I can do is I can do a Boolean difference. And so I select this block, and I do difference. I click this bolt. I hit enter. Now, did it not want to do that? Did it not? Nope, it worked. Okay, cool. There we go. For a minute there, it didn't look like it wasn't done. It was just, it was so exact on that. We're good. All right, so now I have that. So if I were to put an M6 by 1 bolt in here, it would screw in. It would thread. It would work. This is kind of nice because you can get other fasteners. You can print threads in here. You do not have to print threads with support material 99% of the time. So for those of you who are looking at this with an engineering aspect, who are like, hey, I want to make some functional stuff for my cars, or maybe I want to make something that can be bolted in, here you go. It's as easy as this. Now converting those files over, what you would do is you would open the file itself. Let's open these. So we go to 3D printing, and we're going to go to fasteners, and we'll find one of these guys. Let's try this one. I don't know what this is, but it's one of these files. Yeah, SolidWorks. Okay, SolidWorks. So this one probably came from Fastenal or something. And it's an M10 by 1.25. Right? So I can't use this. I can't do anything because it's SolidWorks. So what we need to do is we need to export this as a Rhino file. So we can do mesh to NURB. Actually, this might already be a polygon. Is it already polygon? It is. Okay, perfect. Great. So we just got to save this as a Rhino file. All right, so in this case, we'll save as fasteners, and we'll do this guy here. So here's an M10. Boom. All right, now let's say I want to go and I want to make a really big box here. Let's see. Actually, let's do a new one because this is a pretty large. Let's do small objects in millimeters. And now we're going to draw another box. And let's make this box 50 millimeters and 50 millimeters by 10 millimeters. And now we want to insert that. So we're going to go up here. We're going to go to Insert. Find our guy that we just converted into a Rhino file. Now, it's not going to arrive this way perfectly, so we're going to do rotate. Okay, there we go. Now that's a 50 by 50, so that's, you know, reasonable, like, you know, And we just we want that thread, right? So, but above and beyond that, we want it to go through it. So we also want a little bit of a sink for that bolt head, right? So if this bolt goes down, we don't have that sink in there. So we'll take a little bit of that sink in here, just a little bit. And now, if we do a Boolean difference, move this guy out of the way. And now we have the sink for the bolt for the head, so it's going to be a perfect fit. The thread all the way through the object. And if we render this guy, you can see what I mean. And that is an easy, easy, easy way for you to put fasteners in your objects. Again, a lot of the manufacturers do this stuff because they want people to be able to preview it. So you can preview the object in SolidWorks, but above and beyond that, if you're trying to design something and you're planning on buying fasteners from them anyway, it works great because you can be like, yeah, cool, I want 50 of these things from this company so that I can use them on this. I've already made my object for it. Perfect. I know they're going to fit. So again, there's various manufacturers that do that. Poke around and you never know. You might find some SolidWorks stuff that you can download from their website. Pretty cool, but that's a much easier way. A long time ago, a lot of people used to actually create threads complicated by doing a helix. And so if you go in here, there should be a helix. Let's see. If we do helix, you can do, let's see. It's been a while since I've done a helix. I want to say it's top to bottom. Yeah, here we go. And then starting like the radius and the start point, and then figuring out what the pitch is. There's a lot to doing this. On top of that, you would then go in and you would draw a curved line based on your calculated amount of how big those threads were to make the solid, and then you would sweep the rail and close the surfaces, and you would extract it from a cylinder. It's a complicated process. Or, hear me out, go to your favorite websites that you're going to buy your fasteners from, see if they have those files, download them, convert them, and just use them in your objects. You're just, it works great. It's a good way to do it. And it's much, much faster. Anyway, I hope some of these are useful for people. I hope this is something that you find useful. I'll keep doing some more Rhino stuff because Rhino is my favorite software to use. I don't want to do too many things at one time, so if you have questions, comments, leave them below. If you have feedback, I'm always open to feedback. I understand that I am a new creator, so I know that my content is still getting out there, and I'm just starting on this stuff. So any feedback that you have that's constructive, feel free to leave it below, and I hope you have a wonderful rest of your week.